Hello, this training video for Futron's FieldTwin design is going to discuss and give you an introduction to our wall thickness calculator estimation tool. We released this in the 6.3 release of FieldTwin design, and the wall thickness calculator uses both the API uh, submarine pipeline recommended practice and the DNV recommended practice and does both calculations for the burst and the collapse limit state. Now I've opened up a FieldTwin project and I'm going to show you that if you've had your account admin or your Futuron customer success manager go in and wire up your account to have this tab exposed, you should see in the drop-down menu from the layout the wall thickness estimates or the wall thickness calculator. So when you click this, whatever your default position for setup, that calculator will show up. And this is a fairly large amount of real estate that the UI needs if you want to see all the significant figures of the data going into the pipeline or into the tool. So the input data is on the right-hand side, and the calculated values for a valid connection in FieldTwin will be shown. So I've selected a pipeline. If you don't have a pipeline selected, the tool will say that you haven't selected a valid connection. So I'll come back and select this oil pipeline, and it will grab from the metadata input values that are needed for these calculations. So there are 7, 8, I forgot how many count. There's 8 values of metadata associated with the connection. And then there's kind of project related data that at the moment is kind of a variable that's exposed to the user and exists in the application, but it's not metadata stored for the connection. So we start off with some default values that should be pretty typical for most applications in terms of the Young's modulus or material modulus. We set it in the units of megapascals to be 210,000 megapascals or 210 gigapascals. Poisson's ratio for the material. Again, we take a typical value of 0.3, and the tool needs both the gravitational acceleration constant and the seawater density to calculate the external pressure head that will lead to a potential collapse of the pipeline. And then we're not going to talk about this in this training video to keep it relatively short, but there'll be a separate one that will discuss the elevation reference height, which is only used in the burst calculation for the DNV calculations. Now, as part of turning on the wall thickness estimator tab and exposing this tool, somebody in your project account is going to have to work with Futuron to map and create these 8 data attributes in your FieldTwin connection data model. Because if you don't have these attributes exactly defined as the tool is expecting them, you won't get the tool to function. It's going to query the connection, look for these 8 values, and if it doesn't find them, the tool won't be turned on. And that is done by having Futuron customer success people work with your account managers to basically import at least a portion of our standard riser and standard pipeline data models. So as you can see here, we have a fairly extensive set of attributes that we provide out of the box for accounts that want them to adopt as their metadata models for pipeline connections. So you've got parameters like inner diameter, outer diameter, wall thickness, hydraulic roughness if you're going to use any of the data from FieldTwin to drive flow assurance calculations, and relevant for the design, the wall thickness design calculations, maximum design temperature and maximum and minimum internal pressures. So we can go in and we can have scripts that will automatically populate these metadata definitions and, more importantly, these metadata groups, the standard riser and the standard pipelines. And there's some overlap between the two, but the risers have some specific attributes like the strakes, how much the strakes are being used on your riser as attributes that are not relevant for most subsea pipelines. Then your account admin is going to have to go and look at the connection definitions that you have, and they're going to have to assign the metadata values either by the groups. You can toggle this on and um, only show the groups that need to be added. In this case, we've already added to the oil production connections and the water injection connections the standard pipeline and the standard riser metadata groups, so that when you come back here and have selected and defined a connection to have the type oil production, you'll get the metadata tab, and more importantly, you'll get all the pre-populated uh, placeholders for the metadata attributes. So in this case, I've gone through and I've selected the oil service. You need to know this because this is going to have input into the internal pressure for the DNV calculation. Right now, the um, wall thickness estimates are only valid for single wall pipes and for rigid pipes. It really doesn't make sense to use these recommended practices. They're not relevant for flexible pipes. You need to provide an outer diameter. And again, the default values within the Futron out of the box is we have a fairly extensive set of units you can use. Most typically, we're expecting users to use millimeters, maybe centimeters and inches, but if or inches down here. But if you wanted your pipelines in meters or kilometers, it will work. You need to select your line pipe material. Is it carbon steel? Is it one of these other available steel types? But most importantly, further down in here, you need to tell it what ASME pipe grade material is. Is it a X60 strength pipeline? Is it an X65, X70? Some have questioned why we've put X80 in there. It existed in the design code, so you can select an X80 pipe grade if you want. You need to specify the minimum design temperature or the maximum design temperature. In this case, I'm using Celsius, and you can mix units. The tool converts all of your units, regardless of what unit of measure you select in your particular model, to SI units to be consistent, does all the calculations in SI units, and then will report back out the wall thickness and the inner diameter to match the unit of measure that you select for your pipeline. So in this case, I've selected uh, roughly a 10-inch diameter, a 270 millimeter outer diameter pipeline for 15,000 psi service, so very high pressure, not so high temperature, only 85 degrees. And so, as I would have expected, I get very high wall thickness values to contain that very high pressure pipeline. And it's not too deep. The profile is shown here in this tab, and the maximum water depth is shown as well in the interface. Now, if I were to change the temperature to say 135, so considerably hotter, we should see the wall thickness go up, particularly in the DNV, and we do. And that's because both API and DNV derate the yield stress associated with an X60 pipeline to be less strong, have a lower yield stress as the temperature goes up. So if I took it to 150 F, you'd see it probably go up another millimeter or two if it'll take my data. Let's see if it did. Maybe we hit the maximum for DNV, or there wasn't that significant of change. I can't remember if DNV will take it up to 175 Celsius. Now what we do are, it did. It bumped it up to 48 millimeters. If you want to know more about the background of the wall thickness estimator, we put a lot of it on the apps docs fieldtwin.com website. And here you can see quite a bit of warnings about the intent of this estimator. This estimator is intended to give you just very quick material estimates and is not to be considered a full mechanical design, wall thickness mechanical design. But we've tried to do a good job of pointing out all of the assumptions and limitations behind the tool in this online documentation. But back to using the tool. So that's kind of a quick overview. I can show you that if you prefer to work in inches, and we change this to a 10.625 inch outer diameter pipeline and hit return, we'll get approximately the same wall thickness in inches. Now, if you want to put this back and store it in your metadata model, you can just click on this and either of these two buttons, either select the API or the DNV. And when you click on that button, the tool will push back in the values into the metadata record for that connection. Now, if your account admin hasn't assigned the required metadata to a particular connection, you'll see the message again that a valid connection is not selected. So in this particular demo model, I've left the jumper that's bringing the production back up to a platform to be an umbilical. And so because the connection definition is umbilical, the wall thickness calculator passes back the message that the connection is not valid. Now, if I change this to an oil production connection, eventually the database should refresh, and now it'll bring it up, but it'll show you that the metadata hasn't been populated. So again, if I go through here, select oil production, select single pipe, rigid, maybe I'm going to make this a slightly larger diameter jumper. So let's just say it's going to be 280 mm. You need to put a corrosion allowance, and the corrosion allowance is another topic that could probably use an entire separate session. It is only used in the DNV calculations. So if you have a non-zero corrosion allowance, it will impact your DNV wall thickness. API RP 1111, at least the older version that we were basing these calculations on, does not include the corrosion allowance. You'd have to add that in manually. So let's make this also 15,000 psi. Say 0 internal pressure, and we'll also make it X65. So at this point, our fabrication process. So I have to come back up here, and let's just say it's a seamless pipe. Boom. Now it's got everything, and it's doing the calculations in millimeters because that's what I had given it. And I'll even be daring and grab this one, which again is also an umbilical connection, and label it as oil production. And if I toggle back and forth and it gets refreshed, it should say, okay, I need to go through and select the type. And let me just see. It's got the jumper. It should detect that it's connected to a host and declare it as a riser. At least that's what we had talked about doing. We'll see if the message comes up that it is a riser once I've got all the data populated. So I'm going through again. I'll put the corrosion allowance, we'll still leave it at 0. Line pipe material, carbon steel. It uses that to grab the material model, or I should say some partial safety factors in DNV. All right, what am I missing? Oh, maximum design pressure. How did I forget that? 15,000. Oh, not the temperature. Temperature will be 85. Design pressure 15,000. And internal pressure 0. And it did not. Well, I know if you declare the type to be riser, it should detect it because there are different partial safety factors in DNV for risers. But I know it's been done on a deep water host. So my apologies for picking a project that does not have a deep water host, but we'll have a second tutorial that will show that the tool can distinguish when it's a riser and will use the appropriate DNV partial safety factors for risers. But that's really beyond this initial discussion. I will just demonstrate the corrosion allowance. If I put the corrosion allowance up to 4, you should see the wall thickness in DNV change. And lo and behold, it does. But again, API RP1111 does not include a corrosion allowance factor in its calculations, or at least not the way we interpreted them and put them into FieldTwin. I hope you found this training video useful.